I'm very pleased to be here. Thank you everyone for the invitation and for this honor to be here. Today I'll talk a bit about different fuck-ups that may happen in testing world, because it's a very big world. Also, how to work with different kinds of incidents, because in my opinion, QAs are people who really work closely with incidents and sometimes being a part of incident management without even knowing about it. A couple of words about me. I really like your conference because your motto is from community to community. That's why I put first my community work. I am one of the organizers of QA Club Lviv back in Ukraine. Right now, I'm working in a Dutch startup called Ziver, and I don't know why I put it, but few years ago, I was writing articles to Medium. I stopped, but yeah, some of them still useful for testing mobile applications. And before I start talking, I need to mention that I'm talking quite fast. And if you really find it hard to follow me, you can click on the link or scan QR code and get my slides. I also will try not to read the slides, and I encourage you not to read the slides as well, because I'll be sharing my presentation as a bunch of stories and of useful lessons than just the text. I hope you get enough time to scan it. So what we will talk about today. First, of course, I will share a couple of fuck-up stories being in QA testing career. Then we will talk a bit about the concepts of site reliability engineering and incident management, how to build it properly. We will talk a bit about the customer support and what to do with the customers who face some nasty outage, and how to survive during the incident, because it's quite a stressful event. And I will start with a couple of fuck-up stories when I was a QA. First of them is related to SSL login. So a few years ago, I was working at a company which had a login field with email and password, but also with the Google login. And before one of the rushed release, I actually forgot to check login through Google. And what's worse, that this check wasn't automated by our automation engineers because it was very hard to automate. So for proper automation of login through Google, you need to approve that your Google account is not stolen and that you are really you. And it says kind of pop-up, and you need to click this pop-up. It's quite hard to do during the automated testing. And we ended up having an issue that users were able to log in through email, but were not able to log in through this single sign-on. A few customers were affected. They couldn't log in. We rolled back the release late at night. But yeah, I have some takeaways. Murphy law always works. When something can go wrong, it will go wrong. And if some test cases are impossible to automate, eventually they will be easy to automate. Because in the end, we found a way to automate this case for single sign-on login. Our DevOps has set some specific browser to click this pop-up to approve identity of the Google account, and it was actually automated. But you need to keep in mind that sometimes issues happen. My second story will be about kind of an edge case. In a different company, I was the only QA in a startup. And once I was on vacation, and some of the nasty bug again went to production, but somehow company CEO decided that it was because developers were relying on QA too much, and they were not testing some issues, some test cases, especially positive ones, on their own. And that's actually how my QA career ended up. I was switching to management after that, and it was a decision to stop hiring any QAs after this, and to make developers test it. So what is the outcome of this case? Of course, it's a joke, so do not go on vacation if you're a QA. You should go on vacation, but I want to mention that engineering culture always comes first. If your developers do not test their code on their own, you will always have troubles with relying on QA, with lack of trust, or too much relaxed of being developer when you have a QA nearby. And also quality is everyone's responsibility. But yeah, it was just a story about the QA fuck-ups because everyone has a fuck-up and I wanted to share mine. And I want to talk a bit more about the incidents and incident management. When I was a junior QA, I was facing some kind of incident or bugs, but they were actually very small or not that nasty. Maybe the nastiest one was this missing login for Google account. But then I switched to high availability project when we were processing payment data 24/7. And actually every minute of delay of outage was costing us a lot of money. And that's when I learned about incident management and what to do with this one. And also, why do we talk about this? because shit happens for everyone, even for very large companies which always say that they don't have any bugs, they have perfect automation, they have perfect process for rolling back. Probably you can recall Facebook outage last year, which happened, and I believe they were down for like a few hours. It affected many other companies, it affected logins for many even banking applications. So yeah, just wanted to show that it happens to everyone. Also want to mention about the software lifetime costs, because during the testing process, during the product development process, probably you've been a part of different stages, starting with requirements and design and during implementation and integration. But actually every software product which is used by customers takes the most cost for maintenance, because the product can go live for many years. And that's of course what many businesses want to see. So their product is used to many years, but the most cost comes to maintenance actually. And if your product is stable enough, it's much better cost-wise. A couple of words about the culture. So there is a very famous, it's not a title, but a culture called DevOps, when development and operations go together. And developers cannot really say that it worked on dev, it worked on local machine, and I don't care what happens next after the release. Developers, but not only developers, everyone else actually worries about the quality of their product and availability of their product after release. And I want to mention something called SRE, which says it means site reliability engineering. It's also a kind of title now, but I would say it's also kind of culture. It was introduced in Google back to maybe 15 years ago, like that. Since then, they produced 3 books which are available for free on Google website, and there are many people with title called SRE right now. So SRE talks about availability and engineering, and it's actually kind of mix of engineering, DevOps, operations, testing, everything. That's a culture and a process when you take care about every piece of your product during the whole life cycle. So you don't really stop your support during the development when you send something to your tester or to your customer, but you actually maintain your product through the whole life cycle when it already came to production. And when something bad happens, you as a developer actually maintain it. Just a couple of words about different abbreviations like SLI, SLO, and SLA, since we have limited time. But there are very important concepts in this site reliability engineering culture. So SLI means service level indicators. These are different metrics provided by engineering to product and management, which means, for example, frequency rate or throughput for network. So different metrics related to actually availability of your product. The next level is SLO, service level objectives. These are objectives on a product level, which defined again by engineering, but also by product, to work on. So for example, if you are talking about the request frequency, you can define an objective that your frequency will be at this rate for this period of time. And the highest level is SLA. Probably you've heard this term before. It means service level agreement. This is kind of agreement provided by company for their customers. And it's always defined by sales and customer, by some top management. It means how available your product will be. For example, if you have this payment application, your clients really want to be able to make payments 24/7. They don't want to wait for morning, for example, to send their payment to processing. And your SLA will be very high. It means that your application should be available 99% of time or even more. Maybe you've heard about numbers like SLA 5 nines, which means 99.999%. It's a very high SLA. It means that your product really should be available all the time, almost all the time. But of course, it leads to the complexity of maintaining this product, because sometimes the cost of maintaining this high SLA is very, very expensive. SLA leads to a term called error budget. That means how often during the day or week or month you can be down. For example, for some backend deployment, you need to upgrade major level of some framework you're using. Let's call, I don't know, Java. You need to do a major upgrade of Java, and somehow you need to have scheduled downtime for that. And your developers say to you that you will need 40 minutes to upgrade this. But your SLA actually doesn't allow that. Your SLA is so high that you actually can allow only 20 minutes per month. And it leads you to either changing the SLA or communicating to the customers that you actually will use this error budget. Yeah, so we talk about site reliability engineering culture, but it also is very tightly coupled with the term called on-call. On-call means rotation for, again, mainly developers who are responsible, fully responsible, 100% responsible for their products. Good on-call process means that this is a process that when something goes down, there is an alert, but also somebody reacts to it. And it's usually a developer who maintains this service. So it's not an infra engineer, it's not a QA, it's not a sales, it's actually a developer who is responsible for this one. On-call process also requires some time to spend on it because person who is on rotation usually fixing alerts, improving monitoring, but not working on a product feature, and also needs some green light from the management to work on it. And also good on-call process involves constant improvements, working on automating some stuff, improving alerting, fighting with false positive, avoiding false negatives, and making your maintenance of the product as easy as possible. Good process of incident management also involves something called postmortem. Postmortem is a document or kind of artifact which appears when the incident happened. Usually this document means what happened, describes the problem shortly, also mentions the timeline, what happened when. For example, service went down, in 20 minutes, developer reacted to it, in 40 minutes, developer rolled back, we communicated that to customer, blah, blah, blah. It also means the root cause analysis, and that's maybe one of the most important parts of any postmortem. So what happened? What was the reason? It also mentions resolution. So what did you do? Did you actually fix the bug? Or maybe you rolled back the release? Or maybe you added more nodes on the backend? And also probably one of the most important parts is action items and lessons learned. What will you do to avoid these problems in future? A few years ago, when I mentioned this SSO login case, which wasn't tested by me before the release manually and we didn't automate it, I didn't know about the postmortems, but actually I did this kind of root cause analysis for myself after this happened, of course, after the fire was put down. I also described like what happened, what was the reason, what is the outcome, but the most important, what are the action items to avoid these issues in the future. It's also very similar to the testing culture when you have some bug in production, and I know some companies do it when there is a bug code, you always add scenario from this bug either to your manual testing check or to your automation list of test cases. Good postmortems are blameless. That means that you don't blame anyone. You don't blame somebody, even though this person did some bad deployments or didn't test something or maybe misunderstood some requirements. It also means that you cannot blame yourself, even though it was your issue, but good postmortem doesn't blame anyone, even yourself, even if you're author of this change or author of this document. Good postmortem is blameless, and it means that, yeah, we had some problem, we have lessons learned, and that's what we will do to avoid this problem in future. What I also faced in one of my previous companies when we've been working with the postmortems very actively, that you need to take time to analyze it. Because if your product is very unstable, if your startup is growing very fast, sometimes you have outages or any problems like every couple of days, and you don't even have time to analyze it. So don't make cargo cult out of postmortems, but take time to analyze it and to fix problems on system level, not just fix the symptoms. I also have some good examples of good postmortems from companies like Cloudflare and Roblox. For example, Cloudflare, when they go down, it means that the half of internet goes down, but they're actually very nice as a company in communicating this issue and making sure that they have lessons learned and how to avoid that. I also have examples of not very good communication when some of the companies, recent example is Atlassian, they were down for a few weeks actually for some of the customers, and customers couldn't use their services like Jira, but they didn't say anything to customers at all. So there was a problem. Customers were asking customer support, but customer support didn't even know what to respond. That's a bad example, don't do like this. It's also quite a good thing to do is to analyze postmortem metadata. If you really have many postmortems to analyze, and we've talked about it, you don't do, sorry, cargo cult out of it. It's actually a good idea to analyze what is the key root cause for many of the issues. So it's kind of similar to testing principle talking about the defect clustering, when the most of the defects actually are situated in some one cluster, in some one place. That's actually quite similar to the postmortem analysis, because sometimes most of the issues happen with a particular service. Maybe it's an outdated service or bad architecture, or maybe not enough infra around it. And also how to avoid the system, again, this problem on system level, not to respond just to a particular incident. It's just an example of such an analysis. For example, you analyzed many postmortems and understand that one of the biggest issue was some commit to your code base, which wasn't tested properly. So you can act on it with introducing more automated tests or unit tests. That's just an example. So what do you do if you have incidents, and how to communicate with the customers? I know that some of the QAs really do a part of customer support, or they've been asked first, like what happened, what to say to the customers, everything is on fire. Yeah, so what does good incident management process say when you have customer issue? First of all, separation of responsibilities. That is very important when outage is fixed by one person, but communication at least handled by another person. So developer who is focusing on high priority fix is not asked every second, like, hey, what to do, what to say, what are you doing, when will we have the update, why it's taking so long, etc., etc. So there should be at least one separate person to communicate all the updates. Sometimes this person is called incident commander or incident manager, who actually coordinates this effort and actually shielding people who are working on the fix from angry customers or angry customer support in your company. It also means communication, and it's better over communicate than not communicate at all. Many incident processes, like good practices, advise you to provide update every X minutes. For example, if it's really high priority outage, provide update every 20 minutes. For example, if it's lower priority, provide update more rarely. I believe you might see it if one of the products you've been actively using, you always check the status page of this product. For example, you're using Slack and they have outages from time to time. What I usually do, go to their status page and they actually provide updates every hour, like, hey, we are working on the fix, next update in an hour, like that. Good incident management process also involves proper planning. So if you really have something on fire and you don't have any document template, you don't have contacts of person who can fix it, it's very bad. It's always better to be prepared. And if you have something bad happening, you are always like ready and you can eliminate the problem much faster. And yeah, want to mention also about the handoff. In the case you're working in a company with multiple time zones, when, for example, you work in European time zone and you have colleagues in the US and something bad happens and you actually couldn't fix it till the end, you do the handoff to the next shift of your on-call colleagues in the next time zone. So you just jump on a quick call and discuss what was done, what is the analysis, what are the next steps, what would you like your colleagues to do. What to do with the customers. Don't wait until it's too late. As I've shared before in the examples, there is a great example of Atlassian not communicating anything to the customers when their services were down for a couple of weeks. Don't wait when it's too late, because your customers can churn. You will have very bad reputation, which can be damaging your company very seriously. Don't lie. It's better to say the truth, because again, a lie will uncover sooner or later and will damage your reputation so much that you'd better not try. Even though it was your problem, your fault, we learned that good, healthy culture doesn't blame anyone. We just have lessons learned and we act on it. It's very dangerous to lie. I encourage you, do not do it. Loop in sales or executives very fast. Usually, sometimes when you don't have customer support, you have sales people who talk to customers. It's very important to communicate to them that you're fixing the issue and what is your progress. Over communicate, again, it's better to over communicate, and of course don't lie. And customers will see that the problem is very important for you, and take the responsibility. That is also very dangerous, not to have this on call properly or not to have the process. When something goes wrong, you usually have one developer who can fix everything, some senior, but sometimes this person can be very tired and they can actually quit, they can be on vacation. It's better to have process, proper people in place who can take the responsibility. How to survive during the incident? Sometimes it's very stressful when everything's on fire. People can be freezing, not knowing what to do. I really like this paragraph from the Google SRE book. They say that don't panic. Usually the sky isn't falling and people don't really have physical damage or physical danger. Only those poor electrons are in peril. So basically, don't forget that you're working on a software. Of course, the impact will be very high, but you will be most productive when you focus on resolving the problem rather than panicking. Also, there is a great life hack from paramedics who actually work in emergency and sometimes come to some really terrible situations, to some accident. What do? When they go out of the car, they actually take a time to look at the watch and understand what time is it now. It's very important to kind of bring yourself to the ground, to kind of realize where you are, what is happening, and that you need to resolve the problem, that you don't need to panic. Sometimes it helps with resolving software incidents as well. So yeah, resolve an incident step by step. What should you do? First, isolate the problem, because if you don't have the root cause, it's very hard to fix it. Stop outage from spreading. That's also very important. If you have some nasty bug spreading out through your services or through your systems, sometimes it's better to shut down one of the systems which was kind of infected. But yeah, avoid problem in other availability zones if you have multiple availability zones if you're IFRA. Of course, fix it. Provide the postmortem and root cause analysis. Fix the root cause if it wasn't fixed at the beginning, because sometimes fixing the root cause is quite a long procedure and you just apply some hotfix or roll back the release and communicate with customers. But I'd also add that you need to communicate it to the company, like the rest of your company as well. And talking about how to survive the incident, I want to say that process is always the key. So you have clearly identified roles of your resolvers and incident managers. You have all the drafts and documentation prepared in advance. It's also quite a good idea to have a draft of your status page when something goes wrong, because when something really goes wrong, you don't have time to word it properly and to put nice sentences because you're kind of under stress. Discuss the error budget in customer contract. If you really need to do this planned downtimes, maybe it's better to reduce your SLA or maybe make your error budget higher. Think about the on-call process if you really need it in the company. Sometimes it's kind of clear signs if you have any issues and nobody responds to it that you need to introduce this process. Of course, automate and monitor as much as you can, and not talking only about the testing, but also about the deployment process. Over-communicate. It really shows that you care. Use Chaos Monkey's procedures when possible. So Chaos Monkey is a process introduced, if I'm not mistaken, in Netflix. That's what they do to properly do the performance testing on their high traffic service. What do? They actually shut down part of the services randomly and see if their system is robust enough to survive. That's actually quite a good exercise to try if you really have this high availability system. And read other public postmortems because you can grab some very nice ideas. Conclusions. Shit happens always. If you think that there is something really problematic that can happen, it will happen sooner or later. You just need to be prepared. Process is the key and training is the key, because when a person really starts going on call, it can be stressful again, but practicing this Chaos Monkey exercises helps very much. I have some bunch of useful links. Again, I shared my slides before. I can bring back the QR code slide if needed. There are some nice books, some nice postmortems, some nice process write-ups. Yeah, and that's it for me. If you need to contact me, you can find my small website, or also I invite you to join QA Club Lviv on Facebook. We have some nice meetups. During the Corona, we got online meetups, so we really appreciate everyone joining us. Yeah, thank you, everyone. I'm ready for your questions.
Thank you very much, Diana. It was very nice presentation. Especially, I like the visuals and memes you had. And I think Road is one of my favorite visuals. So, I have a question. As you mentioned, shit happens always. But I wonder that, have you ever experienced a situation like turning a crisis to opportunity?
Good question. I believe that one of my first stories was an opportunity because kind of QA title was eliminated in the company and I needed to step out to some other title. Also, what I've seen a lot, always these crises are opportunity to work on some legacy part of your product or finally work on automation, because I see it a lot in QA, for example. Then there is no time to automate because you are always swamped with manual testing because you need to have frequent releases. But when these incidents happen, finally management see that, yeah, it's really important to automate it.
Okay. Thank you. And one more question. What was the biggest craze you experienced?
Yeah, once I experienced full outage of our system at one of my previous companies. We worked in like partially Ukraine and US, so in different time zones. And I might be mistaken, but one of the US colleagues was trying to update something, but didn't really expect the load. And so he provided some update, rolled out it, and actually went to sleep. And system started throttling in a few hours, and like 5 hours after it, during our working day, all our services stopped. And I believe it took around 30 minutes at least to fully recover. So we actually had this problem with processing payment data, which was quite a big outage. Yeah, it was quite stressful, but I'm happy it happened during our working hours. So we have many people online who quickly jumped on fixing the issue.